Ladies and gentlemen, a very warm welcome here to the forum of the Hydrogen and Fuel Cell and Batteries Group exhibit here on Hanover Fair 2014. Please have a seat, have a drink on the house and discuss with us, because our next topic will be about PEM electrolysers, the next step on the way to 100% renewable energy. And I'm very happy to have here the CTO and co-founder of JOULE, Heinrich Gärtner. Nice to meet you here.
Nice to meet you.
Hello, Mr. Gärtner. Have a seat, please.
Hi.
You're all invited to discuss with us. If you have a question to Mr. Gärtner, just raise your hand and I'll be with the microphone right with you. Mr. Gärtner, JOULE, you're the first time here, but not really. Actually, you're the third time. No, H-TEC is long here, since 20 years already. So, in fact, you're 20 years here. No, this is not true. You founded JOULE just 10 years ago.
Yep.
And you're an agricultural engineer. That's your background.
Yeah, that's true.
How can I understand that?
That's our background. Indeed, our roots are in agriculture business. My colleague and co-founder, Ove Petersen, and me, we studied agriculture engineering in Weinstefan near Munich. And we had the chance to learn, to know each other, and dealt a lot, of course, with an optimal use of land. And in thinking about the best use for land, and in the whole discussion with energy, we thought about why not to use a part of the land for producing energy like our fathers and grandfathers did before.
Right. Agriculture has changed very much in the last decades, didn't it? The most of the farmers today are energy farmers. You can really say that, aren't they?
In a certain way, yes, they are. Usually, everything you produce is a kind of energy. Even if you grow wheat or corn, it's energy in the end.
Right. Yes. If you eat it, it's also energy.
Yes, and that's a preferred way. We did that for a lot of years, but we also fed our cows and an ox to draw a cart or something like that. And nowadays, I think we have a more advanced way to use energy with a quite higher efficiency.
And then you decided, okay, then let's do it directly. Let's plan big energy harvesting with PV installation. You broke the world record with the world's largest thin cell system in the megawatt class 10 years ago.
Yes, that was in the year 2004. We built indeed one of the biggest, at this time the world's biggest thin film PV plant. PV had the advantage it was scalable, and it was a quite simple technique for us to install, and we had the chance to talk to the banks to get the money for that. I think it was a great deal, and it worked, and we had a story since this date.
Indeed, and you went on in this story of 100% renewable energy. You also included wind projects and biomass projects, and now you're taking the next big step for future energy projects.
Yes, over the years we have learned that production of energy directly with the solar installation is one step, but the mix is necessary to get the next steps on the way to 100%. And in the consequence, it was after picking up all the production sites and all the techniques to produce the renewable energy, to think that in the next step about storage of energy.
It is a shame, actually. If we look at Germany, we have more than ever renewable energy in the grid, but at the same time, more than ever, CO2 in the air. So this doesn't fit together, does it?
Yeah, that's a little bit a problem in our legislation at the moment. On the one hand, we have the renewable energy law that promotes building of renewable energy sources and gaining electricity from renewable sources. But on the other hand, we have that market with the carbon dioxide, and that doesn't work really together, because you still have the allowance for a significant amount of carbon dioxide to be put in the air, and on the other hand you just have the renewable energy law, and that doesn't work together, that doesn't work in line at the moment. So
we need new solutions, integrated solutions. What is your solution?
There are several steps to go about that. I think in the end we need to have a fair price for carbon dioxide. At the moment it's just too cheap to pollute the air, and as long as it is that cheap, you won't see a significant change in in the numbers.
The CO2 certificate don't really work, do they?
No, they don't really work. I heard they work, but they work on such a low level that it has no effect at the moment.
So we need a fair price for producing CO2. If we had this fair price, many of good projects would be very successful, wouldn't it?
I think if the price for carbon dioxide would be in a fair level, we don't have to talk about prolongation of the renewable energy law or all that, because we are cheap enough at the moment. The problem is that indeed the low carbon dioxide prices are subsidies for other ways to gain energy.
Indeed. But of course, we have a lot of renewable energy, and we all know it's volatile. So sometimes the sun is shining, sometimes the wind is blowing, and at other times it is not. So we need some solution for this peak shaving. I will say that if you have a lot of renewable energy in the grid, we have to take it out and to store it. How to store it?
Yes, we have an office in the very northern part of Germany, and we see that really often they have to shut down the windmills to stop the production.
Which is a shame, yeah.
Yeah, because the grid has an overload, and that are times we can, of course, gain really cheap energy because you can't use it in another way, and to store it. And that's in our eyes the next step on the way to 100%, to take that exceeding energy amounts and store them in a long time storage. And
how will you do that? With batteries?
We think there are a lot of systems and a lot of techniques out there. From our point of view, the hydrogen technique is very flexible. We can use that in several ways, of course, for long-term storage, but also in material usage in a lot of several ways. And one, of course, is, from our point of view, that you have a lot of infrastructure in Germany where you can use hydrogen to bring it over existing pipelines, for example, to the point of use.
And the infrastructure is the gas grid, actually, because we have the best gas grid in Europe, so we can use it.
Exactly, yeah, that's our point of view.
So what is your plan? You take the surplus of energy out of the net, let the wind blow and let the windmills work, and produce hydrogen by electrolysers.
Indeed, with the rising amounts of renewable energies in the German grid or in the European grid, we see bigger peaks, and of course we have to deal with them. And of course you have to keep a steady flow of energy. Of course, every time you have to produce the same energy other people are using at that moment, and for that reason it is necessary to always have the right amount of energy. That's a goal in Germany, that you don't have too much breakdowns. Of course, we know that in other countries, but in Germany you are not used to that, and of course we have to keep that in mind, that we don't have that fact. But for that reason, of course, we know we have to store energy and we have to bring it back to the grid in the moment it is needed. And for that reason, of course, we think about that storage solutions.
Okay. For that, you come from PV and you come from wind and biogas. You found a partner, you found a subsidiary, which is H-TEC now, and they are producing PEM electrolysers. And they also producing it on a large scale, or they're able to produce it on a large scale. That was very important for you, was it?
Yes, it was, indeed. We think that we have the chance with that mass production able technique to get the costs really down. Our goal is over the next 5 years to get the price for the changing electricity into gas down to around about 2 cents per kilowatt hour. That's our goal, and we have calculated on that a lot of times, and we see with...
Very ambitious, indeed.
Yeah, yeah. But we're really convinced to do that.
You can do that if you produce the electrolyzers on a large scale, and the energy will be for free.
Of course, yeah.
Okay,
that's just the cost for transforming the energy. Yeah.
Don't forget the taxes. You know, they always take taxes on anything. They live on taxes, actually. The government will take taxes even from this free energy, probably.
At the moment, that's really a big discussion that with electrolysis systems we have a problem, because we don't have 100% of efficiency. Of course, we have losses we have heat production next to the gas, and we have a problem that we have to pay a lot of taxes and a lot of fees for the energy we can't feed back to the grid. Indeed.
Okay. Yeah, the efficiency is not too bad actually. So you have 75% or so with the PEM electrolyzers, but the problem, as I've understood it, is you pay when you take the electricity off the grid, transform it to hydrogen, and in the end, when you repower it, the end user will pay the second time. So they pay twice for the same energy.
Yes, that's indeed the problem, that we pay these consumers fees 2 times in the end, when storing it in the storage, and then when we bring it back to the grid, or when the consumer needs it and uses it.
That's not fair, I would say.
No, that's not fair, and I think we have to address that point to the government, to the politicians, of course, and we do that regularly, and we see something in movement, but still we have to talk about that issue.
I learned, Mr. Gärtner, you're in the board of the Energy Storage Association in Germany, so you can move a lot about this way, can't you?
Yeah, that's indeed one problem that doesn't have to do just with hydrogen. It is a problem for almost all techniques of energy storage. It depends a little bit on the efficiency of the storage system, the impact of the fees, but of course we are working on all levels.
Yeah, hopefully the politicians will be convinced to skip this double fee, consumer fee. But let's get back to the whole process. So you take the surplus renewable energy from the grid, transform it to hydrogen. Well, then you have to store the hydrogen. How can you store the hydrogen then? It's very voluminous, isn't it?
Yes, the energy density is not too high, but our electrolyzers have an output pressure of 30 bar, and that is usually a good way to store it in steel tanks. And usually where we see our electrolyzers installed, we have enough space for enough storage.
Okay, yeah. Because your electrolyzers will be right somewhere in the landscape, not in houses.
Decentralized storage of energy is our thing.
Okay, so but what do you do when the grid needs power again? So you have to repower it then, the hydrogen.
As I already said, it's very flexible how to use hydrogen. But of course, one idea is to feed the electricity back in the grid, of course. And there are several ways. We prefer, as one of the low-hanging fruits in the first step, already existing combined cycle engines, and just add the electrolyzer and the storage tank, and then you have a complete system. There are a lot of biogas plants where they already have installed 90% of the infrastructure you need.
See, okay,
And on the other hand, you just have to add the electrolyzer and the tank, and then you have storage and production facility.
So where already existing biogas plants are producing heat and power, you just, you value up the biogas with hydrogen. Is that what you're planning to?
Yes, that has an effect on the efficiency of the biogas plant, of the combined cycle engine, but on the other hand, we have the chance to reduce the amount of biomass that is needed, and to get a higher power level in the end for the whole plant. On the other hand, we have the situation that you don't have the need to feed in the grid, but also to take out of the grid to get it leveled. And that the electrolyzer works in that way, that you can take electricity out of the grid if you have an exceed, and that's important too.
Very interesting, yes. That's what you already said. You have already 90% of the infrastructure. You only need the electrolyzers as a surplus, and can build up, like you say, a power gap filler. That's what you say about it. Yes, that's the idea. Okay, if you have any questions, just raise your hand. I'll be with the microphone right with you. You can ask your questions right away here to Mr. Gärtner, who is here with me. Mr. Gärtner, you decided to use PEM electrolyzers and to buy H-TEC, and they're producing PEM electrolyzers. But we all know in this power-to-gas business at the moment, there's a lot of talking about alkaline electrolyzers because they're cheaper. What do you think about that?
I think alkaline electrolyzers, it's a sort of proven technology. There are much older and much longer in the market, of course. On the other hand, we see a lot of potential of reducing the costs by reducing the used material, the input material to build an electrolyzer. And our H-TEC electrolysers are built really of thinnest slices of material and with really low part of expensive materials, and that's important for us because on that basis we we can build it bigger and cheaper with the mass production, with the leverage of
so you're really counting on the scaling effect in the end. So if you really sell a lot of these electrolyzers and produce them in large numbers, you will bring prices down, but still you will have platinum in the PEM electrolyzers, don't you?
Yes. At the moment, that's the basis. Our membrane works on that basis, but I think over the years we will see if there are
maybe
better
there are other materials replacing platinum. Then yes,
maybe.
We will have talks about that here in the forum as well. So maybe there's something coming up. Very interesting. So there's another thing about electrolyzers in Germany. If you think of the old photovoltaic panels that are on houses installed, let's say 20 years ago, and people run out of this funding and don't get the amount of money anymore, they want to use it themselves, but they also need a storage opportunity. Wouldn't be your PEM electrolyzers then a good opportunity to build it also in houses?
Yes, we think when we reach a significant amount of stacks we produce per year, then they will be cheap enough to take these solutions in our focus. It is possible. At the moment, it's quite a little bit too expensive maybe for single households, but of course our focus is still on decentralized production and decentralized storage. And I think we'll see that over the years coming up. I think we have a question over there.
Oh, very good. I didn't see that. Thank you very much. You're just in my back, so I couldn't see that. Here you are.
Thank you very much. Ellie Rustling from Rochester, New York. And I am very interested in the PEM fuel cells. But one issue that recurrently comes up is that element of efficiency and the losses. If you could explain a little bit how you've overcome the efficiency issues.
Efficiency is good point at PEM electrolyzers, aren't they?
Yes, of course. We have restrictions in efficiency, of course. With our stacks at the moment, we reach an efficiency of 76% in transforming electricity into gas, into kilowatt hours of hydrogen. But on the other way around, to bring it back to electricity, of course, you still have a loss of 50%. Depends on a little bit on the technique you use. Is it a gas turbine? Is it a combined cycle engine? Is it a fuel cell? It depends on that issue. But we think we can cut that problem a little bit because we are decentralized in our production. And usually, as I told already, the low-hanging fruits are the installations where we already have a grid to use the heat. And we produce, of course, heat, and on a level that's okay for heating households, for producing water, warm water, and all that. And in small scales, that works really, really great. And that's our one point for decentralized production. Yeah.
I could imagine the next step to say, well, let's do it. Let's produce the hydrogen and then repower it also with biogas together in large stationary molten carbonate fuel cells, because they can take gas and they can take hydrogen, and they also produce a lot of heat, and it's the same system but much more efficient in the end.
Yeah.
Maybe that's the next step for you. I'm looking forward to that. It was a pleasure talking to you. Thank you very much for your attention, being here. I would like to advise you to visit the booth of JOULE and H-TEC Systems at B40, just down the aisle this way. Thank you very much, Mr. Gärtner, for talking with me here on stage. Thank you very much.